So today we start with a Uniden 100 in its box. I put down a cloth because it's the customer's pride and joy, so I won't be putting it on sandpaper like I would if it was one of my sets. So it's in a box. So 1981, we won't power it up, but what we will do is to change the capacitors. I think he's changed the front because it was a worse front onto a better front, and it needs something like the TX RX Lite rewiring or something down those lines. We're going to be taking all the lids off because we're going to be changing the capacitors. So there's the two 220 microfarad capacitors need changing, the two 470 microfarad capacitors need changing. Whenever you see these sets, that's what needs happening now. If they haven't failed, they'll fail tomorrow. They'll fail in the middle of your on-the-air test. One of the symptoms is no display. If the 470s fail, it can take out the audio IC, which is very expensive. It's an MB3712. I think last time we had them, they were about £19. So if you spend a couple of 80 pences, you don't have that expenditure, you see. So by having the cloth on it, it's still got the plastic on it. I haven't printed off a sheet yet. Right, I'll go and print off a sheet. Right, so I've got my sheet of paper. Take this off. Remember, these are 16 ohms. It's difficult to get the right one. Possibly even impossible to get the right one. So we need to get rid of these capacitors before powering it up. And positive is the white dot. These are also glued down, which I can feel the glue. Positive. Yep, to the top on that one, 220. Get rid of that. It's that one. Yep. Positive to the white dot, and probably the most important one is that one. I've got my printed circuit catching on the thingy. Why can't I see the other one? Don't know. Can't. These are ideal for cutting your toenails with. So 220 there. Positive to the dot. 220 there. 470. And the ones I didn't clean out. Yeah, it's somewhere up there. Using leaded 60-40 solder. Why did I get those big cutters out when I used them to get the capacitor actually out? We'll go over this with isopropyl alcohol to tidy it up. And it's that one which didn't get desoldered. Very dull solder. It's like it's been in a damp environment for a long time, which is possibly true. Oops. And only at this point dare we power it up. Other capacitors can play up, but there's no kind of blanket ones you've got to change. Yet. If we've got an ESR meter on here, possibly not. I'll hang on to those. I'll get an ESR meter. Right, he's sent a power lead. Oh, we're not going to bother with it though, are we? We'll get the connect. We'll just do it this way. It's more fun. Right, so I've got that in there, that in there. Power it up. It's come on. For some bizarre reason it says 19, which we know there's only silliness on that channel. I'll go and find a Uniden mic. It's the one which isn't labelled. No, it's not. It's a 6-pinner, that. Oh, I don't know where the one went. I've got another one out of stock. If I remember rightly, you can't control the PA volume. Testing 1 2, testing 1 2, testing 1 2, 1 2 1 2. Yeah. You know what? I think I've got them in the wrong socket. I have. They're stamped on the panel, not that easy to see, especially if you've got eyesight like mine. Testing 1 2, testing 1. Testing 1 2, testing 1 2. So as I say, you can't control the volume. It's stupidly thought out. You'd have to use one of those ridiculous power mics, wouldn't you, and use the volume control on that. It's not the only sets that do this. Disappointing, but that's how they are. Anyway, it works on PA. So I've done 2 times 220 microfarad. I've done 2 times 470 microfarad, and we've got the meter lamp working, and we've got PA working. Back to CB. And I need to connect my earth lead to some kind of earth point. That'll do. Right, we'll go through it. Picture in picture on. Correct meter. We're on channel 20. Turn the volume down for now. And we're in a 3-watt scale. You know, I did press that right button, but it didn't happen, did it? We're not going over to the right switcher. There we are. Right, we're getting an aerial plugged in. Well, in this case, the test equipment, which of course incorporates a dummy load. It's doing more than 3 watts. It's doing 3.5. Channel 40, it's doing 3.45. Channel 1, let's guess, 3.55? No, 3.5. Back to channel 20. Transmit current is 808 milliamps. And low power is 0.2. Deviation, for what it's worth on this test set, wow, 3.2. See what it is when we get on the proper reading test set. 3.2 hertz. We'll be doing the VCO shortly. Can't adjust the frequency on this type of set, so let's hope it's somewhere within legal limits. Good grief, it's spot on. Yet the Euro version, they did have adjustable frequency. 27.79128. That won't change. 27.79128. So we'll put that into the signal generator. 27.79. We'll put 128 in so it's accurate. Let's see what we've got. Put the cyanide meter on, switch to the cyanide meter. One day I'll reset that camera position, which the mice move in the night. Not as normally as sensitive as Cybernet chassis sets, but this one is an exception. I'm going to have to hold on to the chassis for the reading. 0.45. Very good. For 10 dB, 0.38. Often they're only just under 1. And it's got the good one here. And for 20, I can just say it's 1. Exactly 1. Squelch. Take that to full. I'll show you the attenuator. 1, 3, 10, 30, 100. I want it to open as 100. It doesn't. It opens at 2.5 millivolts. So that's a bit too harsh. That's a lot too harsh. But at least it does open. And our threshold, so turn that back to 0.3, park it there, put it to standby, turn the squelch down on the radio, set threshold, signal generator back on, 0.85. So even with it up like that, it's still okay, but we'll adjust it. S meter, it's supposed to be, for 100 microvolts, it's supposed to be S9, and dare I tilt it up, it's spot on, spot on. I expect when we've tuned it, it won't be. I'm going to put the pen somewhere. There we go. So that's right. Switches are working, potentiometers are working, sockets are working, and on transmit we're not doing 3.5 watts. When we key up, it's probably about where it should be. Right, we're going to have to do the VCO. We have to always do the VCO on these. So I need the realistic service manual. Ugh. Take that off for now. Which has the VCO instructions. So resistor 52, it's a 2001. So resistor 52 resistor 52 is there. That's our test point. We have you go to channel 40. And it's a floating earth, so I need to put an earth on the meter to a can or to your actual power supply earth. So you transmit on channel 40 should be 3.5 volts. It's 3.62, so we don't need to adjust it. And that's plus or minus 0.1, so we're absolutely fine. You can see the wax hasn't been messed with, so we're not going to have to go any further with that. On receive, what they want you to do is they want you to adjust L18. So if we just go back to that one, Yes, it is. L18, they want you to adjust it for maximum output to an oscilloscope on channel 20 on test point 3. And test point 3 is resistor 53 down there. We don't need to do that because it's not like the set isn't working. If you're at factory level, it's like I was saying with deviation. If you were doing thousands of sets, you'd have a dummy mic plug, you'd have a signal generator, you put it in, you're going to transmit, you'd set the deviation to whatever the service manual says you set it to. But we're doing these individually. So because the set's already working, we don't need to bother with the oscilloscope, we're just going to have maximum synad. We'll come back to that later. So that is fine. So it's 2.2, did I say? Whatever. Putting it in the wrong box. 2.2. It's fine. Right. So we're going to do the transmitter. Back to channel 20, centre of the band. We'll put the meter away. I think the biggest time is going to be connecting the LED. Right, let's go to the main meter. Centre of the peak. It's there. That one's correct. Ooh, fraction there. Change tools. Put some heat on that. I'll just tell you what the service manual says about power. It's supposed to be 3.7 watts. A normal operating unit is supposed to be 3.7 watts, and we are at 3.6. So we can let it do 4. And there we are, it's doing 4. We'll check the other channels. Channel 40 is 3.95, channel 1 is 4. So having done that, we need to do low power, don't we? Back to channel 20. So it's now doing 300 milliwatts, but it needs to be doing 400 milliwatts. The manual says 350 milliwatts, but the law said 400 milliwatts, and of course that's now not relevant because that was taken away in 1994 that you had to do that. So it's a very useful feature, especially if you're in a convoy. So full power, the radio is now drawing 875 milliamps. Very efficient. So we'll go to the deviation meter on the test set behind me and hope it isn't really 3.2. Spot on 2.5p. Wow, that's great. That's of course why we use the test set for deviation. sometimes the Marconi is right, sometimes it isn't, because it needs the capacitors doing and I'm not doing them. Right, so it was 2. It is 2.2 to 2.5. It's 2.2 to 2.5. It's spot on. VCO is 2.2. Spot on. So we need to just look at the meter. Make sure it's in the centre of the red zone when we're going to transmit. So we turn the power up. It may have altered. It actually could do with coming up a bit. RF meter is there. Centre of the red zone is there. Right, receive. So I'll just put my earth back on for the receive audio. First thing we're going to do is put the camera on the oscilloscope and we'll set the detector. And the detector, without looking at the manual, is going to be there. Absolutely spot on as it was. I think we'll do the IFs first. It's well set up, this, isn't it? Turn it down a bit from there. Still showing you the oscilloscope. I intended showing you the synod meter. Move that across a bit. Little bit there. That one was spot on. Right, let's see what we can do with the front end. That was absolutely spot on. Spot on. Fraction there. Six, 5, 4, 3, 2, 1 are the ones we're supposed to be doing in that order. Fourteen's on the transmitter. Just go back into transmit. And then that one, which is the injection into the receiver, which was right. So there's been there is a little bit there happened. So let's see what we've now got as a result. Again, I'll hold on to the chassis. And we've now got what? 0.51. Yep, we've got 0.51. That tells us the detector was a bit out, because it's a worse figure, even though I know we've gained on the receive. It's 10 dB, 0.45, and it was just 1 before. It's now 0.95. So the detector must have been very slightly out, which has affected those figures. But now the clarity will be there. So, squelch. So I've got the signal generator on 100 microvolts. So we need to adjust the squelch so that it opens. So I've got squelch on full on the radio. If it will, of course. Put it up a bit. Squelch isn't quite where I wanted, but it's a little bit better at 1.6 millivolts at full. Let's turn it down to minimum, see where our new threshold position is. Well, hopefully better than that. Let's give it another go. That was dreadful. .9. Well, it was 85 before. Oh, I'm not holding on to the set, am I? Let's try again. Yeah, holding on to the set. It is the same. I'm putting 0.87 because that's what it's showing this time. So we've got half a watt more out of it. We've skirted around the receiver. Let's just check that once again. (12 dB, 0.51). Yeah. 10 dB, 0.44. I've got 4.5, and then an improvement 0.85. Yep, that's where we are. Right, here comes the hard part. And that's wiring up the LED. You can only actually see one wire. Is there only one wire and the other one's kind of mounted somewhere else? Just cut the end of that tubing off, which is a bit damaged. I think we're putting some WD-40 on that so I can get it down the tubing. See whether that's all we need to do. Put the mic back in. Put it on low power so we're not thrashing the transmitter all this time. No, it's not as simple as that. Wouldn't be, would it? I know these are different, but there might be a wiring diagram which gives a bit away. TX indicator, white to the anode, orange to the cathode. And then perhaps the LEDs had its been snapped off. Yeah, it's snapped off. Well, that's fun, isn't it? So they're glued in. Yeah, so there's the orange wire. There we go. Right, I'll have a look in our... I mean, I've put a new one of those in, but on the other hand, I might have a... Well, I say I might have a scrap one, but by the time we get to buy sets, where's the front, you know? That's the problem, isn't it? Yeah, we'll get a new one. Actually, there is enough left when you take it out of the rubber. There's enough left. So if we... So, which one is which? Well, the flat... It says the flat bit is cathode. So we've got the flattened bit. And theoretically, that's the wire we've just soldered on. In which case, it's the orange wires goes to it. We need that sleeving back, don't we? hopefully that works. I'll switch the set back on while it's in bits. Good. So I need to glue that back in. And is there... So another point there where the service manual was really useful to have. The realistic manual. Oh, what does it say the receive's supposed to do? We've got 1600, haven't we? So that's, well, I might think it's awful at tight, but it's within the limit spec. Oh, sensitivity is supposed to be 0.5 at 10 dB, and it's 0.45, so it's well within the nominal, let alone the limit. Good, nice radio. So I'll put this back together, and it'll be on the air test time. Just pop some isopropyl alcohol on the other side of the board. Right, that's done the isopropyl alcohol. Just pop that back. I did spot a potential dry joint. So these don't suffer from dry joints, but anything can this age. That isn't the one I spotted, but may as well do that. May as well do that. Trouble is I can't spot it now. Oh, I have. Yes, I have. Good. You know what? I'm gonna find out which is the positive, which is the negative, even though it doesn't matter anyway. Well, that's... Oh, I bet your mic return goes... I bet the earth return goes through the mic. Yep, that's negative. Away, it's getting hotter. As soon as I put this together, we'll be straight onto an on the air test. The only 1981 sets I've got new in boxes are, and we've used them for reference, are the realistic ones. So 2000, 2001, which is the smaller Uniden, the 2002, which is a GRE one, same innards as used in the TRC 3000 base station, the 2003 remote, that one-hander set, and that was it, wasn't it? Until much later on, with the 2005 CPT only set sold from Maxon. The only base station ever did was the TRC 3000, which, as I said, uses that GRE chassis. Right, get the proper screwdriver on it. So it's Sunday evening, it's about 7:15. I suppose they're all watching religious programs on the television, so there won't be anybody on the air. Tell you what, we'll swap the signal generator for the aerial. Switch picture in picture off. Switch the test gear off, save some electricity. One and a Roger. Right, we'll leave it at that. So, doing on the air test. Thank you for watching Uniden Uniace 100 from 1981.